when we left off last time, we had just done our basic indifference mapping. We learned some of the basic changes, how the model looks. Today I want to kind of go into, I guess, what I call complex indifference mapping. Just to kind of do a little bit more with the model than just, one basic change or whatever. And the first one that I want to look at for complex indifference mapping, I'm actually, to be honest, I'm personally a little hesitant to look at it just because it violates one of our initial assumptions from when we set the model up. But the book talks about it in actually quite a bit of detail. And then if you look at like the end of chapter practice and stuff like that from the book, they actually address it quite a bit. So I was like, oh, we better at least talk about it, just so it can kind of fit in with the reading. And that's to kind of go with the idea that when we modeled our goods, we kind of made the assumption, we were given the assumption that we liked everything. That effectively more was preferred to less, so getting more of the good made us happier. And I still believe that assumption that's true. However, the math also allows for dislike. Remember, we even addressed this when we put like a utility function up on the board and we said, hey, some components could be negative. And that in theory, if one of the components was negative, it could be enough to make the entire solved equation negative, which implies dislike, effectively reducing your utility value. If that's the case, the math allows for it, and as the book, talks about it, we should at least be able to model that, and we can. So if we have any two goods, I just use X and Y. That's what I used a lot. And I have, so you remember on before, our utility curves kind of curled like this, so they kind of pointed, the bow pointed to the origin. What if I had some where the bow pointed away from the origin? So for example, if I just come up with some starter utility functions that look kind of like this. Where they're still nonlinear, but now they're not driving to the origin, they're pointing away from it. Well, some of our rules still hold. As you go away from the origin, utility should increase. So if I find the very closest point to the origin on the graph, it occurs right here. That's got to be my lowest level of utility. So I'm just going to make up a number. I'll just, again, u equals 10. As I move away from the origin, my second furthest point is right here. That's a higher level of utility. So I'll call that u equals 20, and then again, my third furthest point, I'll just make that u equals 30. So we still see that utility is still increasing as we move further away from the origin. So let's just hold good y constant at any level. I'm just going to y bar it. And if I do that, if I do that and just say, we'll pick a spot right here, right in the middle, I can measure some level of good x. What happens if I change the amount of good x? If I increase good x, so before increasing our goods, we said, yeah, that makes us happier. But now look what happens if I increase good x while y is constant. Well, I would have this point right here. So this change from x1 to x2, increasing good x, look at the effect it has on my total utility. I went from 20 to 10, right? Measured smiley faces. 20 smiley faces to 10 smiley faces. Effectively, this increase in x we'll call it less happy. This increase in x made me less happy. So I got more of this good, and I am less happy. Kind of leads me to believe I must not like this good. I think that belief is strengthened where if we go to the other utility function, u of 30, and you'll notice that, again, holding y constant, the point where that bar, y bar line, hits my utility function, I have some x3, which in this case now is a reduction. And as x is reduced, what's happened to my utility? It jumped from 20 to 30. I got happier. So in this case, the decrease in x made me happier. So clearly, again, another strong indication that I just don't like this good. If you take it away from me, I'm happier. If you give it to me, well, I'm less happy or sadder. I don't know if that's a word, but we'll roll with it. I'm sadder. So clearly some measure or some indication of dislike. This also, really quickly, because this will be important as we get into our elasticity effects coming up here in a minute. Typically, anytime we do a quote-unquote like a test on a good, we're going to put this on the horizontal axes. So this implies dislike of good x. It is actually possible that you could dislike both goods. You would curl it so it points away from the origin. But again, the book goes a little bit more into that. I don't like that because I don't understand the point of modeling utility generation for two things you don't like. Again, the whole point of this is to model our choices. So I mean, that's kind of, I kind of like sticking with that. We like our good choice, but again, the math allows for it. So the graphical possibilities must exist. So, all right, we've got kind of one of our complex situations out of the way. The next of our situations I want to look at is called a corner solution. And I have a nice formal definition for you. A corner solution occurs when the utility maximizing optimization point has a tangency located at the corner of the budget constraint and thus the consumer purchases only one good. It's kind of long, I'll repeat it. Corner solution occurs when the utility maximizing optimization point. So that's that tangent point. That's, the optimization point, it's that tangency, right? When the utility maximizing optimization point has a tangency located at the corner of the budget constraint. So last class, we were making everything look nice and pretty. Our tangencies were occurring like right in the dead center of the graph. They don't have to. It's cleaner, it's neater, but it may not be realistic. In theory, there are infinite number of combinations that could be represented on this graph. So if that's true, any of those infinite number could be a tangent point, as long as it satisfies the mathematical requirements for tangency. Well, if that is true, then it means that, well, those tangency points could occur where you're purchasing zero of some product. So let me just give you some examples. And I made this up, so this is maybe for me, maybe not you. So what if there was like cardinal games and romance novels, where each of these products may yield some measure of utility in whole or in combination. But for me, my optimal combination of cardinal games and romance novels would occur right up here, where I get all cardinal games and no romance novels. And I could have a utility curve that is still tangent at that point, right? So, you know, I'll draw it out like this. And again, if we could kind of go into that pretend theoretical space on our colors, you know, maybe it kind of continues into that pretend space, right? And it looks now like a utility curve that's tangent exactly at that budget constraint. And you know, there could be other utility curves as well. I'll just kind of draw these with dots. You can or don't have to put them on your graph. Right, where maybe there's some U2, where you'll notice that U2, I can't buy any combination. They're all beyond my purchasing ability. And then there's some, you know, maybe there's some U0, where yeah, I can buy a lot of these combinations here. But, you know, some combination of romance novels and cardinal games. But I have the ability to be happier, to be up on that U1 level, right at that tangency. So, I mean, maybe that one kind of makes sense. You'll notice if we just kind of focus, well, I guess if you focus on any of them, but especially on the initial one, that utility function seems to be kind of flatter than our budget constraint, pretty much at all points within our model graph. That's going to happen every time we have a corner solution. You're going to end up with one of those flatter curves to lead to that, you know, for a corner solution up on the vertical axes. That is not the only corner solution that we can have. The other corner's in play too. Give me a minute to draw this one. Art, not a super strong point of mine, so I kind of have to futz this one out a little bit. So again, I'm going to set it up the same way, where I have some initial budget constraint. And I could have a solution where it's exactly tangent to my budget constraint down here, where I'm only purchasing good X. And in this case, my utility curve kind of is steeper. And again, you know, we could put the same thing on here if I were to continue this out into, you know, negative space. But we can't. We can't have negative good Y, where I can't go to negative cardinal games. So, you know, if we continue that out, it gives that more traditional utility curve look, but it's now just occurring at a tangency down here. So my vertical axis corner solution occurs when the utility function is flatter. Then the budget constraint, my horizontal, is when my utility curve function is steeper than the budget constraint. And again, the same kind of idea exists. I could have some parallel looking utility curves, U0 and U1, just like we did a second ago. U1, I can't afford any combination. U0, yeah, I can afford combinations of both goods X and Y. I'm just happier right here. So I would probably spend all my money to get to that happier point, and it's just occurring where I'd only purchase good X. Okay? Good on corner solutions? Yeah, fine.
I just have a question. So, like, when you do, like, a value person, so the U value when, like, the one to the right, would that be less or more?
This one right here?
Yeah.
More.
So that's
Happier.
like more. Okay.
Yeah. So, you know, again, I mentioned this a lot of times, but I'll kind of use U1s, U2. If you always want to just call it, you know, like U equals 20, U equals 10, and U equals 5. If that's easier to see, by all means. There will be some, we won't get to it today. I wanted to set the math proof up today, but we didn't get far enough in the first hour either. There will be some that we will eventually be able to calculate. And if we calculate it, okay, give me the number that we calculated. But if not, go with whichever strategy you like. If you like U1 and U2, that's fine. If you said like, hey, it's just easy for me to visualize 5, 10, 20, perfect. So whichever way you like. Okay, any other questions? All right, I'm going to do a board clear, and we'll go to our next one, elasticity effects. Okay, so now we got to combine our indifference mapping with, unfortunately, one of our probably most disliked things from not only 1900, but maybe even earlier this semester, and that's the idea of elasticity. And the reason we have to combine them is because our indifference mapping captured price change, right? Remember we did price change yesterday? That was the pivots in our budget constraint. So if it captures price change, there were some things we had to think about. One of them I mentioned last time. Hey, if price goes up, make sure your quantity goes down. It's the law of demand. Perfect, that's great. We remember the law of demand, but then we factor in elasticity. Price goes up, Q goes down. Does it go down a little or a lot? Because those are both choices, right? It can go down a lot, and we said that was elastic. Or it could go down a little, and that was inelastic. And yesterday we didn't worry about it. We made everything perfect and right in the middle of the graph, so it just everything was proportional, which is also a possibility. But we want to be able to capture that. And it's kind of difficult because when you think about it, we're kind of measuring, goods X and Y against each other. There's got to be some relative measure. Keep in mind we are assuming a society that only has purchasing of two products. So that means we can measure them relatively together. Typically what is done, again, and I've mentioned this, is the good we're testing is going to be on the x-axis. The y-axis represents our spending on anything else in society. So I've kind of come up with my own little abbreviation for that. I call it AOG, all other goods. Meaning, again, if we live in a world of two goods, we can always look at it as some relative measure. So if we just consider our other good anything else you could buy, we actually can determine elasticity effects based on how does our spending of on one product change relative to other goods that we might buy in society. Okay, so let's just maybe explain more as we go. So why don't we say price goes up of an inelastic good, right? And we can identify inelastic goods at this point. We have several examples. Those are the ones that are, you're really price insensitive to, addictions, needs, things like that. Okay, so watch out for some of those, especially if the goods are specific. So price up of an inelastic good. I'm going to draw this a little bit bigger. You may want to as well. And sometimes I try to pre-plan these when I'm doing it because I know what's going to happen with my cues. But for this one, I'll just go ahead and start everything in the middle as you maybe get more used to it. Maybe sometimes you can pre-plan them. I don't know. So here is my income at P1. And I'm going to just go ahead again and just put an optimization point right here in the middle. And remember, this optimization point was a combination of some goods X and some other good in society. I'm just going to leave this alone for right now. I'll fill that. I know we should do a starter graph, and I should have a variable here. I'll fill it in at the end. So I'm going to leave it alone for right now. Okay, so X is our tested good. We're going to say it's inelastic. The price is going to go up. When price goes up, we can buy fewer. So I should get my what can I buy line closer to the origin. So it pivots in. So now I've got I at P2. And again, it's pivoted inward. Now for me, I kind of work backwards on this one. I know some people are really good visual, again, spatial and artistic representation, and that's just me, not me, so I need to kind of work a little backwards. I'm gonna force, in essence, the inelastic effect. I want Q to go down a little. So I'm just gonna make a little change. I'll say like right here. And I'm gonna, since I'm working backwards now, I have to dot up to my new budget line. And I'm gonna put a point right here. And it's this point that I'm going to now draw my new utility function. And it's closer to the origin, so it's pivoted in, which we expect. We're not happy if prices go up, so we're less happy here. And I've made my change in X small. Now this is what we mean by right here, with this idea of, relative, matching it relative to other goods in society. Because honestly, on any of your, papers, especially if you draw it small enough, your change in X could be small. How do I know it's really inelastic? Well, how does my behavior respond? What happened to the purchases of other goods? Well, initially, I was buying some measure of my other good right here. Now, I cut it back, and I cut it back significantly. I cut it back more relative than my cut back of X. Price of X is what's changed. You'd think that would be what I stopped buying. But no, I actually stopped buying a lot of these other goods. This is what we mean by relative. This is how we can tell the good is inelastic. Because I am willing to reduce my consumption of AOG a lot to try to prevent my X from falling. Now it's still going to go down. Law of demand over there. Sorry, it's still going to work. But we are willing to sacrifice so many other goods so I don't have to sacrifice as much of X. In essence, the relative distance between the two, so here and here, and here and here, we're willing to give up a lot of all other goods so I don't lose as much X. Okay, so that's kind of the picture one. I understand sometimes people need a story. Remember, inelastic goods are needs, right? These are things we need. These are things that are addictions that we, have addictive qualities. If that's the case, let's think of something that might be, maybe a need. Well, it kind of got cold today for the first time. You said it was snowing. Who said it was snowing? Evie said it was snowing in Illinois right now. Yeah, that got cold quick then. You need heat, right? And if the price of heat goes up, you don't be like, well, no, it'll just be cold. Yeah, you might have to cut back a little. But what do you really start cutting back on? You start cutting back on everything else that you might be buying. You reduce some of your other expenses. You don't go to a hockey game. You don't do all so you can still get as much heat as you can. If you're still going to respond, your price, will fall in the wall fan, but you don't want to cut it back as much. So you stop doing other things so you can still try to get as much heat as possible. Okay, make sense? All right, real quick, because I can do it in 4 minutes, I think. We'll do an elastic one. Okay, so again, I have some starting x1. I'll go ahead and fill this in over here, AOG1. And again, I still kind of think a lot of times that it's kind of good to just maybe force the change right away. So I want the big change. So maybe I'll go like to here, x, and that's still, yep, perfect. So here's my x2. And I can put a point on here representing utility 2. And you'll notice that in this case, I've considerably cut back on X. I might have to still cut back on all other goods because, you know, prices are going up. That means I don't have as much discretionary income. But I didn't cut back very much. Most of my drop occurred with X. I will say there is also a little just kind of quirk with elastic. You don't see it really with any elastic. But with elastic, and we'll deal with this more when we get to chapter 4. In theory, you could also cut back so much that maybe you buy more other goods. You could substitute toward them. That's fine as well. Again, it's effectively saying a negative and a positive. So again, the relationship is clearly a relative elastic relationship. So if you did do that, some of you were probably thinking like, oh, why couldn't you just go here and say more other goods and really drop that? You actually could. And we do see that occur with elastic products to some extent. It's not really an issue with inelastic ones, so I don't really worry about that from there. But again, I got that large relative change. Okay, questions on elastic and elasticity effects of this model? So the working backwards, maybe it's just as me because I do suck at art, but we will actually do that a couple of times. So I do apologize if you're a person who really can just visualize it quickly. That's just not me.
How do you price increase in elastic?